75. If I said your angle is 15, what would be your supplement? You would have to do supplement. So
65.
So we know to do complement, you just do 90 minus, supplement, you do 180 minus. Alright, do I need to write out how to work one of those? So yesterday we were looking at some things with finding x. So let's say I gave you some pictures. We did a few in the first section, we did some yesterday, and I'm just making these up so don't be surprised if we get ugly answers. Alright, if I gave you that and asked you to find x, what would you need to do?
Combine them equals 180.
Right, a straight line is 180 degrees, so you should be able to add these things together to equal 180. So we get 8x plus 2 equals 180. Divide. We get 22.25. If I had, I'm probably not going to work this out, but let's say I had given you the same type of thing, but I wrote it like this. What would you do there?
Something equal to each other. Wouldn't you just set it equal to 90
Yes.
for both of them?
It's a right angle, so you would add them up to equal 90. If it's a triangle, what do all the angles add up to? 180. So lines and triangles are 180, right angle is 90.
So when I said the right angle to 90, it says 2x minus 3 equals 90 and then or plus, I think.
Yeah. And if it was a triangle with three angles, you add all three to equal the 180. Yesterday, we talked about some of those special angle relationships, but I wouldn't ask you to actually name them or anything. I would just ask you to be able to solve for something in a picture. So pretend those lines are parallel. That's a really crooked line. If I gave you something like this. Okay, I'm not asking for a name between these angles. We just have to figure out the relationship. And if we remember from yesterday, my two options are those things are either going to be equal or they're going to add up to 180, right? So when I look at this, what do you think?
That's equal to 180.
They would add up to 180. Okay, if you don't remember anything else I taught you yesterday, look, this angle, is it acute or obtuse? Acute. This one is obtuse. So can they be equal to each other? No. So if they can't be equal, they have to be supplementary. The way we could get it from yesterday, we know corresponding angles are the same, so this would have to also be 3x plus 7, and then they make a straight line, which is 180. So in this case, you just add those up. Do I need to work that out, or you guys can handle it from there? If I gave you something like this. Could you find x and y in this picture? What would we have to do? to give you another measurement to find x, don't we?
Yeah.
Yeah.
I was lost on that one too.
Hold on.
We can solve y.
Yeah, we can find y. Let's find y and then I'll put up a measure to find x. Okay, so if we multiply, we get 9y equals 90. So y is 10. And because I made up this problem, this side does not come out pretty at all. Let's just do that number. Let's make up something here. Okay, so how would I find x then?
X over 14 equals 9 over 6.
I could do x over 9 equals 14 over 6. A couple different options for setting up that proportion. So we get x equals 21. Hey, I didn't do too bad at making up a nice problem. Alright. We okay with that one? You had a couple word problems on the homework, like 57 and 61, where it talked about shadows. So it would say, a person is 6 feet tall and has a shadow of 3 feet. When you draw that triangle, the 6 feet tall, what side of the triangle is that? The vertical. Where does the shadow go? It's on the ground, the horizontal. So it would give you those shadow problems. So you would have to draw 2 triangles for that. Do we need a sample like that, or you guys know how to do it? Draw the 2 triangles and then you're solving it just like this type of problem. Alright, there's really only a couple other pieces that we had in these sections. We talked about coterminal. So if I asked you to find a coterminal angle to negative 230 degrees, what do you do to get coterminal? Add 360. So my coterminal angle is 130 degrees. What if I had said your angle was 500 degrees? Subtract 360. And you get 140 degrees. So at coterminal, you add or subtract 360. Your goal is to have a number between 0 and 360 at the end. So far, so good. What if I said So we start with the 250 times per minute. So we call that 250 revolutions or times per minute. I want degrees. So what does it mean by revolution?
1 revolution is 360 degrees.
Where would I put the revolutions? Top or bottom?
Bottom.
Bottom, so they cancel. So 360 degrees is equal to 1 revolution. So then those would cancel. So we've got the degrees, but that's all I want. Currently I have degrees per second. So what other information are we given? Or sorry, I have degrees per minute. What other information are we given? Seconds. So first let's change this into seconds. What would I multiply by? 1 minute is 60 seconds. And we have to put the minutes on top so they cancel. One has to be on top, one has to be on the bottom. The last piece of information in the problem is 3 seconds. So we have to just multiply by that 3 seconds. So you multiply the top, 250 times 360 times 3, divide by the bottom, so divide by 60. And what do we get?
4,500. Divide by 60.
Oh.
Wait, so you multiply the top and divide it by the bottom.
So we do 250
So times
360 times 3. That gives you the 270,000. Then divide by the bottom, which gives you 4,500. Is that one okay? You get it? The last thing that we did was working with degrees, minutes, and seconds. And we would convert between the two. Do you guys remember doing that? So if I said you have 28 degrees, 36 minutes, 17 seconds. And I asked you to turn that into a decimal. So to get a decimal, we basically need to get a decimal as a part of a whole. So we have to divide. So we had to think, we know the degree part doesn't change. So it's still going to be 28. But for the minutes, how many minutes are in a degree?
60.
So you did 36 divided by 60. For the seconds, how many seconds are in a degree?
60
Oh,
times 60.
no.
3,600, right? Because we want seconds in a degree. Alright, so then you just type that whole thing in. 36 over 60 plus 17 over 3,600. And so I get 28.6047 degrees. If I wanted to go the opposite way, turn this back into minutes and seconds, do you guys remember what you would do?
You would take that bottom number, times it by 60, and then times it by 60 again.
So you take your decimal times 60. Think about, to get a decimal, we divide it. So to undo it, you multiply. Good morning. Hey, you want your notes made up?
Yes,
please?
please.
I just asked. Alright. So if we multiply that, this is 36.282. That's the minutes. So currently the degrees don't change, so we still have 28 degrees. This is 36 total minutes. Now if I want seconds, we take that decimal and multiply by 60 again.
So that first one was per minute.
Yes. So that gives me 16.92 seconds, so we would just round that to 17 seconds. two sections. Any issues with any of that? Did you do it right? So here's what I would like to do. I'm going to give you this